Welcome to Northwest Nuclear Laboratories. We are live and we are now starting the recording for Teams. Okay, Teams is rolling. And so we have Marielle, Rishi, Vasu, Annette, and Alex tonight. Okay. Leavenworth is still there, huh, Alex?
Yeah, it is. There's surprisingly still quite a lot of tourists going there.
Oh, interesting. Okay, I'm going to send David up to the front of the room here. I'm going to actually go with him because he's got to get plugged into the air supply up there. Okay.
Hey, Carl.
Hold on just a second while we flip to David because no one can see David. David. There's David.
Carl.
Hello, everyone.
Oh, Carl.
Yeah.
Should I go grab some gloves? This is Caleb.
Ooh. Yeah, can you go ahead and navigate and everything? Evan, maybe you just need, here, I'll just help him. Yeah, otherwise your hands will fry. Oh, would you bring me back a pair of large? Thank you. You know, doctor, heal thyself. Oh, good grief. I didn't do it either. Okay, Dave.
All right, tonight the discussion for everybody is going to be on biochemistry. If we can get, there we go. And I want to take just a minute to explain to you why I'm qualified to talk about this. I have a Bachelor of Arts in Scientific Writing from Ohio State University, a Bachelor of Science in Zoology from Ohio State University, 10 years of experience doing biomedical research at different medical schools, 25 years of teaching chemistry, 6 years of graduate school in immunology. I also taught high school biology. So I have some experience in this area. There we go. So the first thing I want to talk about tonight are pipettes and pipetters. As you can see on the screen, there's a variety of types. The first one is called a Pasteur pipette or transfer pipette. The second one is a what's called seriological pipettes and can be used for transferring substances and can measure them accurately. Transfer pipettes cannot make accurate measurements, but the next one can. In order to use the serological pipette, you have to use am I on camera now? Okay. So this holder is used with the serological pipette. You put it into a solution. There's a knurled wheel here. You turn that and you get the flow of liquid up into the pipette. This is accurate. You can measure. This one happens to be a 5 milliliter. To dispense it, you can simply push it down or push that down. If you have this pipetter, and they're for different sizes of pipettes, then with this one, once you've taken liquid up in, you can push this bar on the side and all the liquid will dispense. How many of you have taken chemistry? All but one of the people here. How about the people at home? Can you put
Taking
your
it this year.
hand up if you've taken chemistry? How many did we get?
I see 4.
Okay, 4 out of 5. That's pretty good. So there's only 2 of you that haven't. So that means you're going to know, most of you already know the answers to the questions I'll ask. Now the next one is a micropipetter, the last one there. And these also come in different sizes. You set them for how many microliters you want to pipette. This one happens to be a 10 to 100 microliter. You turn the knob on the top to adjust it to how much you want to take up. The tricky part for handling these, once you get the proper size tip on it, this has a lever, a button you push on top, and there are 2 stops on it. So the first stop, you push down, put it in liquid, let the plunger up, and the liquid will go up in there for the pre-measured amount. Then when you want to dispense it, you push it down to that first stop, and then you push it down to the second stop, and that dispenses everything that's in it. It's a very accurate way of measuring out very small amounts of liquid. With the larger pipette that does anywhere from 100 microliters to 1,000, or 1 milliliter, you have to have these blue tips. And it becomes very obvious because they won't fit with the wrong tips. These can all be sterilized so that you can do sterile work if you need to. What we're doing tonight, that's not necessary. Okay, back to the PowerPoint. So the first thing we're going to talk about is serial dilutions. I had some students last year who were trying to measure out like 1 nanoliter, and none of our instruments will do that. You can't. So what you have to do is serial dilutions. There we go. So serial dilutions are used both in biology and chemistry, and they're used a lot. So you need to know how to do them. For example, if you've got a concentrated solution, but you need a fairly dilute solution in order to work with it, then you've got to do a serial dilution. If you have a 1 molar solution, for those of you who are not in chemistry, molar is moles per liter, moles being a number. But then you need 10 to the minus 6 molar solution for the next step in your procedure. Then you have to do a serial dilution to get it down to that concentration. Another example, you have a solution that has 3.4 times 10 to the 9th viruses in 100 milliliters. But you need to have 1.2 times 10 to the 3rd viruses. So you've got to dilute that 1,000,000 times and have it in 5 milliliters. So you have to calculate that and then work out how to do the serial dilution to get that. Well, how do you do that? Hit the wrong button again. So the key to making a dilution is the formula. M1 V1 equals M2 V2, where M stands for molarity, or the concentration, V stands for the volume. M1 V1 would be for the first solution, the one you start with. M2 V2, the second solution, the one you're going to end up with. When you make your serial dilutions, you do have to consider what are the practical limits. If you need to measure out 1 picoliter of something, our materials won't do that, our equipment. So, for a serial dilution, you have your full strength stock. If you take 9 milliliters of water and then put in 1/10 of a milliliter of your stock, then you're diluting that down. And I give the concentrations there. I stole this from somebody and something doesn't look right to me. Yeah. It should be 1 mil of stock, not 1/10 of a mil. 1/10 won't work. But you keep doing dilutions like that and you can get it down to a much smaller concentration. Next thing I want to talk about is pH. Who can tell me what pH stands for?
It's the
Always
concentration of
good when we do
hydrogen
chemistry, I don't
ions.
remember what pH
substance.
is.
I heard a concentration of hydrogen ions.
Yeah, more or less. Mm-hmm. pH stands for power of the hydronium ion. Well, what's a hydronium ion? If you've got 2 water molecules, they tend to give up a hydrogen and transfer it to one of the other water molecules. And so you get H3O. And that means you've got a charge on it. It ionizes. And water does ionize all the time. The water that gives up the hydrogen ion becomes an OH negative hydroxide ion. So pH mathematically is the negative log of the hydrogen ion concentration.
Dave, let's pause for just a moment. You folks are all watching the PowerPoint. We're going to help David here because he has a problem with his headphones.
Yeah, come on.
So
The bar is all the way forward on top.
I see it. I see it. I'm going to work it up.
What happens when you got a bowling ball head?
That's what happens when you get a bowling ball head. Okay. Okay. Are we getting close?
That's good.
You think that? Can you function there? Okay.
Help me this again.
All right. We're on with the show.
So, with these pH calculations, you get a range, usually 0 to 14. Very rare instances you can go above 14 and below 0, but that's extremely rare. 7 is a neutral pH. And less than 7, 0 to 7, is acidic. Greater than 7 is basic. So here, common pH paper. It's used a lot in the lab. And the paper has a, are we still on the PowerPoint?
Yeah, we are, but I'm darting out to look at you too. You're so beautiful.
So the indicators are made of dyes. Often they're taken from vegetables. And for instance, if you cut up some red cabbage and boil it, and then put it through a sieve, the liquid that comes off of that will be a good pH indicator. And they change, different ones change different colors. And so with pH paper that you can purchase, those are the colors that indicate the pHs. And that's because of different dyes within it. Now, you can also use pH meters in order to determine pH. We have the one on the left in our lab. We don't have the one on the right. It's a more fancy one that allows you to do a number of different things. This gives some of the indicators. There's an unbelievable number of indicators that can be used. And one of the best things about it is that the low pH is where it starts. The high pH is where it ends up. And some of them go through a number of different changes on the way that will show this. And it happens at different pHs. And that's what we're going to use for a little procedure we're going to do tonight. You memorized that chart, right? Okay, we're going to do a procedure in a few minutes where we will mix various indicators with buffer solutions having different pH values. Test will be run using a microtiter 96 well plate. And that's what the plate looks like. And along the side, there are letters, A through H, for each row. Across the top, there are numbers, 1 through 14, for each column. So if you say D3, besides being well, no, D wouldn't be in bingo, would it? B3, which is in bingo, would mean go to B row, third one over. Okay. And this is the chart you're going to follow to put these solutions into the wells of the microtiter plate. The rows, each row is a different indicator solution. And there are common abbreviations that we use. At the bottom of this chart, I've given you what the abbreviations stand for, like res is Resarin. And then each column is going to be a pH. And these are buffered solutions that I made up, so you'll be putting those in. Now, one of the things that's said at the bottom of that, do the rows first. So that means you have to put in the indicators first. When you do that, you want to make sure that you're putting in the proper amount. And it told you on that, and I'm going to have that sheet in the lab for you to look at too. And you want to be sure you put in the proper amount. You do that first, then you add the pH buffer solutions. And that's because that will help it to mix better. You want to make sure, as you're putting in the pH buffer solutions, that the tip of the pipette does not touch the solution, because then you'd be adding one indicator to another indicator, and that'll just mess up your results. Okay. Now, when I do this in the classroom, recall I said there's 96 wells. So I have my students do this. Excuse me. Then I pull out my tray that I make up and compare it to theirs. And any well that's wrong is minus 1 point. So if they got them all right, that's 100. That's their grade for the day. And if they got 10 wrong, they got a 90. So you're still at an A, at least for some schools. So I won't be grading you so much tonight, but we'll be taking a look at what your results are. So our next step, oh wait, got another slide. The end. So that's it. So our next step is we're going to go into the biochem lab, and I've got chairs for you to sit in after you get hooked up, and then I'll tell you what to do.
Okay. Caleb, why don't you go ahead and exit first? Give me a heads up when you've landed in there, okay? And then I'm going to send people back to you.
Can I get you, Carol, or somebody?
We'll get to you in just a second, David, please.
Okay.
Evan, can you go ahead and help David? Okay. Caleb, I'm sending Caitlin back to you. Are you ready?
Yep.
Okay.
Just set that on the table in there. Thank you.
Coming over to disconnect you. Hang on.
Thank you. That's that on the floor.
Okay. Good. I think you're back here. And go on back.
Yeah, they're hard to turn. We may need to get some oil on those or some. I'm going to. What's the spray? Okay, I need 2 of you on that side of the table and 2 on this side of the table. All right, we're going to start here. I've got a green solution. So I want to have each of these to have 9.9 milliliters of water in it, distilled water. Okay? So somebody needs to get distilled water in the beaker that's labeled distilled water. And distilled water is on the floor right there. One of those 2 is open. All right. Now, how will you know when you have 9.9 milliliters of water in each tube? Well, these don't go that high. These go up to 1 milliliter.
Folks at the table, please don't hesitate to speak up. Make sure your mics are on because we've got a whole bunch of people out there listening.
Can we just pour until it hits the 9 milliliter mark?
Perfect, yes. These tubes have accurate markings on them for volume. Now, the only thing is, you're not going to see 9.9 on there, but you're going to see 10. So it's not going to make that much of a difference to put each one at 9. No, let's do it differently. Let's do 9 milliliters. 9 milliliters in each one. So go ahead and start doing that.
It's the best way.
Now, what's a meniscus?
It's like the bottom of the curve.
Excellent, that's right. And that's what you want to make sure you're reading, because water climbs the walls. It has adhesion. And so you have to make sure you're reading the bottom of the meniscus for your volume. And it needs to be at the level of your eyes. Would you see if there's another beaker on the shelf that's just about where your head is right now, or a little above? To your left, there's a beaker. Yeah. Put some distilled water in that so 2 people can be doing that at once.
Does this look close enough? No.
You're the scientist, you decide.
Yep.
Now, if it's not, transfer pipettes can be used to adjust the volume very carefully.
Is this? You want to do the next one?
Have you used these before?
No.
Have you?
Mm-hmm.
Okay, why don't you take the 1 to 1,000, one of them, and then set it for 100. I'm sorry, set it for 1,000. I keep forgetting, I changed my mind to make it work better. Okay, get the appropriate tip. They just grab too hard in there. I end up pulling them out with my fingers.
Is it this one? Okay.
Remember now, you're going to go down 1 stop, bring up the liquid, make sure you've got the liquid all the way up in before you pull it out of the liquid.
Mm-hmm.
And then when you dispense, you go to the second stop. So start with the green. Yep. Perfect. Hand that to somebody, the tube to somebody so they can, yep. And now get the first tube that they've got water in there. And dispense all of it.
Does it have to be touching the water or not?
Doesn't matter, but no, it doesn't.
Okay.
That's good. Now hand that tube to somebody.
It's the cap.
Throw the tip away. Okay, that's my fault. I did not mention about how to throw the tip away. Now, where's the one she just did? Okay, right here, this is an eject button. So when you've got a tip on there, all you got to do is push that button, and it makes enough to tip off very easily. Now, where's the one she just did? Okay, take it out. Shake, invert several times. Want it mixed up well. Okay, your turn. You're going to get a new tip. Why are we getting a new tip?
Because the other one's used.
Well, true, it is used, but what does that matter? It's just green.
To be sanitary.
Okay, we had a certain concentration. If we don't change the tip, we could be transferring some of the more concentrated stuff into the other. I had a friend who had an oral questions for his PhD, and they said a student did a serial dilution and came up with so many bacteria per milliliter. What's wrong with that? And he had to think and think and think before it came to him. The concentration of bacteria he came up with was more than the mass of the entire Earth. And it's because he hadn't changed the tips. He made a serial dilution. So now let's put a label on this. So what do you think we should label it? Ignore this, that's for something else.
Oh, okay. Should we just label it a number? Just one or something?
I'm sorry, I couldn't hear
Can
you.
we just do like one? Label it a number?
Okay, what is that dilution right now?
Stock 10, 12.
You had 9 milliliters of water, you added a milliliter of the green dye, so what is your dilution now? Anyone?
10%?
Pardon?
10%?
Yes. So you could label that 110, 110. You could label it 0.1.
Do you want me to put on a piece of tape or just
No.
write directly?
Oh, there's a white area that's meant for that. Putting a label on. Okay, remember it's one stop, bring it up, and then when you dispense it, you push it to the second stop. Have you tried pushing it? Yeah, go ahead and try. It's fun. Okay, so now you can give that to her because she's going to take out 1 milliliter. Make sure it's still set for 1,000. And once you get-
Are we taking out from the direct solution?
No,
Oh.
no. Because that wouldn't, you'd get the same answer.
Oh, I see.
Yeah. So now keep it vertical. Now, somebody hand her the next tube. So you can put that back in line. Yep.
Do you want me to eject?
Now we want to mix that real well. And we need to label that. I'm getting a tremendous amount of static. It's very hard to hear them.
I understand.
So what's this one going to be?
1/100.
Okay. What would that be in powers of 10?
10 to the negative 3, 2.
2. Yeah, that's right. Okay, continue on. Around the table we go.
So 2 clicks down to
Dispense.
dispense. Okay.
Yeah. Only one to pull the liquid in. Label. Is that one labeled?
Yeah, that
Okay, that one is. You can actually label them ahead of time, it doesn't matter. I think I'll need your help, Carl, with the settings on the special photometer.
Okay.
Yeah, I don't like the way they designed that either. Too hard to get them out. You can go ahead and label that one while you're waiting.
do you want to label that much?
Now, what would happen if you didn't mix it real well?
The numbers would be off because you
Way
wouldn't be getting the
off.
exact like.
You are correct.
Just want to do the last one.
Rishi, sound check. Can you hear me?
Yes, I still can.
Okay.
Right. Now I want to turn this around so our at-home audience can see. Do they look like they got more dilute?
Yes.
Yeah, I'd say a lot. Practically clear down at the end, right? So we'd like to know just how dilute they got. So we have an instrument that can determine that for us, and that's called a spectrophotometer. That's what this is. And so it has a well here, and you have to put a cuvette in that well. So we need our cuvettes, and I don't know if I can reach or that I can describe where they are for you to get them.
We're gonna like swap air with someone for a second. Or?
Hey, Evan, I'm going to pass you his hose. Would you plug it in directly up over your head? It's a free one.
Actually not seeing anything.
Valve's not on. Yep.
Answer the hoses.
This is the dance of the hoses, folks. We knew we'd get here.
These are cuvettes. They are designed so that with just a very small amount of liquid, you can get a light ray to go through here and then measure that. So what we're going to do is take each of those tubes and put them in, let's try 100 microliters. I'm not sure, I don't recall what these hold. What's it say here? Yeah, it says it all in German. Okay. So let's put a label at the top here, because that won't interfere, and label them with the numbers we had on there. And we need one for each tooth.
Mr. Fink,
Pardon?
For every stage of the serial dilution, how can you be sure that like the concentration is equally dispersed within the solution?
By mixing it very well, looking to see if there's anything staying anywhere that it shouldn't. Nope,
Okay, you're hung up in somebody's hose.
I am.
Here, let me just unplug for a second.
Nope,
you
you're
can.
fine, you're
oh,
fine.
alright.
I got it. Have you filled one yet? Okay, go. You're doing 100 microliters, right?
Is this one a different size? I don't think it's really
Remember I said there were 2 sizes?
two sizes.
And if you try to use the blue with the wrong size, it won't work. I push and nothing happens. Is it the gloves?
Okay. Fix A.
Yeah. Ah. Okay, that's 100 microliters?
Yes.
I don't think so.
100?
This goes from 10 to 100. Yeah, that's that on 100.
Do you want it to be 1,000 to start?
It shouldn't take that much. That's why I bought these cuvettes. But, yeah, let's go with 500 microliters.
500? Okay.
And you don't have to
Okay, okay.
take out what's in there, just add to it. It'll be fine. And once you're finished, I need to have another cuvette with distilled water in it.
Do you want us to label these?
Yeah, put the number up at the top, because the light doesn't shine to the top part.
Oh. Not bad. Okay.
Do you mind projecting this
I
one
need
for me?
to do mine real quick.
Evan,
Thank you.
do we have a paper towel over there on the wall? Okay, Evan, over up above the sink.
What's spilled?
Yeah, I spelled mine. Do I have to put it in a whole new cuvette or?
No? Is that supposed to be?
I know I spelled some.
Oh, okay, I see.
Thank you.
Oh yeah, I forgot. I couldn't find Kim wipes. I thought we had a whole box.
Do you want me to put it in a new cuvette?
No,
or-
just keep adding.
Okay.
Because our volume in there doesn't matter as long as we're above the minimum.
Basu, can you see clearly what's going on?
Yep.
Hey, David.
Yeah.
How much distilled water did you want?
Put a mill in there, about
Sorry,
1
say that-
milliliter.
oh,
Do you think I should put more in? No, I think it's okay.
You see how there's a narrow track in the cuvette and then it spreads out?
Mm-hmm.
We want to be sure that that narrow track is full.
Do you think it needs a little bit more, or it's just fine?
That's going to do it.
All right.
Did you label that cuvette? You got the water one done? Which way does the holder end up when it's got the light going through? I know where it needs to go. It needs to go through that way, but I don't know which way it's actually going in the spectrometer.
I'll do the first one. Should be like that.
Okay, thank you. I don't know how to change the wavelength on the setting. It's at 600 and I want 550.
Yeah, this is a fixed wavelength.
I think I need a different program.
Let's just try. No, that didn't.
Exit.
Yeah. Sample 550. Okay, that That's what I just keyed in,
Okay.
which is wrong. It's not.
Well, that one says blank, and that's what's in there right now. But we do want the 550 nanometer wavelength. And up at the top it's saying 600.
Yeah, this is.
I'm having a problem with the spectrophotometer at the moment. So what I want to do is set those up here in numerical order. We'll come back to that later if we have time. Did you see where I got the cuvettes from? Could you put them back there? That shelf all the way in the back on the left. One, two, three, four, five, six, seven. So we should have 6 cuvettes right there. Yep, we have 6 samples.
I don't think any of us actually did like more than the one we got before.
Okay.
Yeah, we need to do the 100,000.
So you're gonna have to get cuvettes
One
back.
100,000.
Do 2 more.
Okay, David, I'm gonna take a look here. I brought up a different one. In my so fixed right now is set up for that one. Okay, so I go over here to more and I get scan wavelength, and it would appear to me that if we scan it, we have from 190 to 1100. It should give us a readout somewhere in the 550 range.
Yeah.
I would say right now, because we need to do some more research with this machine, that's our best bet.
Okay.
So is it
It's got the blank in there now.
We need the 100,000. Oh, it's Say again? 6? We have one of the 10, 100,000, 10,000.
okay? It's lamps warming up.
Does Carl have one, or is it the distilled water one that he has?
David, we have the 1 in 10, 100,000, 10,000, 100,000. Did you mean 5 or should we have 6?
There are 6 tubes. We should have one for each
Oh,
tube.
one for that
We
one
need
as
this
well.
one, that
Okay.
one. That's the one we're missing.
Thank you. Thank you.
Now, when we get it working
Did you do the wrong
properly,
one? Was it the 100,000 that we needed?
Yeah.
This one was supposed to be 100,000.
Oh, okay.
Did you?
Is it 100,000? No, it's not 100,000. Okay.
Or get started with the. You want to get started with that one?
now to set the
wait.
spectrophotometer, we have to set it for the wavelength of green. How would we find out what that is?
You need 400 more. Here's 400.
Anyone? How would we find out what the wavelength of green is?
Wait, so this one is 1 in 10,000? Okay, so we should just pour it back.
It's reading, David. It's not done yet.
Is that me?
Well, when it's done, that's going to be just that line holding across. I'm guessing.
Well, that's what we want.
Yes.
Oh. I don't know how the whole two go apart.
Here, I'll go ahead and take care of it.
From, oh, no, I'm not surprised. Okay, I'll try one more time. Set the spectrometer. We have to know what the wavelength of the green is. How would we find out what
Okay.
I know what it is. You don't have to look it up.
Oh no, no, no.
Tell
My
me
like
how you find it.
audio.
Online.
Oh,
Yeah,
my.
Wikipedia. I pulled that up and had it in a second. Okay? So green is 550 nanometers. So right now we're scanning all wavelengths.
Okay. You're definitely not transmitting. I need to look and see what's going on here.
Can you hear me now?
No.
Okay, can
Can you hear me now?
No.
something has gone south with the mic. Okay. Hold on. We'll get you a mic. Hang on. Now try talking.
Can you hear me now?
Thank you. Oh, it's not
Can you
even
hear
the
me
right
now?
one.
Can you talk again?
Can you hear me now?
Slightly, yes.
Okay, it's better than it was. Just you have to. Let me go make an adjustment. What happened? Okay, hang on. Start counting to 10. Start counting to 100 and don't stop until I get back.
3, 4, 5, 6, 7, 8, 9, 10, 11. On the right road. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Glad I didn't have to go into the 30s. I might have messed up.
How much do you put in?
You're like really loud, by the way, David. You're really loud, by the way.
Am I?
Yeah.
Carl, they say I'm really loud.
Well, you know that you're loud, but that's kind of like a man of her opinion. Anyway, no.
I'll just whisper.
Okay, well you're coming across great at that level. Okay, I'm adjusting while we're talking.
So we put a hundred microliters in each. Okay, all right. Sorry. Okay.
Okay, David. Hello, David.
Okay. A B C D E F G.
Hello, David.
We put it in each one.
I think so, and then we're gonna put some kind of indicator in.
Did you stop hearing me? Because I was calling out there.
Yeah, and I was answering. I kept saying yes, yes. And then I just started counting.
Okay. Bizarre.
Not the first time we had trouble.
David, can you hear me?
Yes, I can hear you.
Okay. There's going to be some extra rattling, folks, for right now because we've had to clip the microphone directly to his hood, and
Are you
that's
pushing to the second stop when you're dispensing?
Oh. There one of that one has some help.
Yes, there is.
Do you mind throwing this way for me? Thank you.
Do this one next, and I'm gonna start from the bottom. Around the good signs. I'll just close that.
I picked it out for
Was there something in here before already?
No.
change color.
Because it's like there was benefit already in there or something.
Well, they were cleaned out by students the last time they were used,
When was the last time they were used again?
a year ago.
let's just keep going. Now, are you sure this is the way they make vaccines?
It's a step.
Try counting to 10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, hang on. I'm gonna go run and try something real quick.
way you guys are sharing the work. When I do this in the classroom, there'll be a team of 4 people with 1 microtiter plate, and 1 person will be pipetting and 3 will be watching. And that's why it takes them 2 hours to do a simple lab.
Dave, how can you hear me now?
I can hear you fine, except there's a lot of static, so
Yeah, well, that's you moving.
I'm holding perfectly still right
And it's perfectly quiet.
now. Okay. We should play music during this, like, I can see a rainbow. All the colors of the rainbow. Goodness, you guys are good and fast. Good technique all the way around. Why'd you stop? Why'd you stop?
Should we be putting these ones in the pH column? Sorry.
Yep.
100 microliters again? Oh.
No, what's it say on the sheet?
Oh. Okay, so 200.
Start with 12. I'll start with 1.
100 milliliters again?
What's it say on the sheet?
Oh, never mind.
We have 1 indicator, so that
It's 200 on the.
No, I didn't do double tubes on the buffer, so that means you have to share.
should we do like a we do 1 through 6, you do 12 through 7, and then switch off?
Should we do a thing where it's like you guys do 1 through 6 and we do 7 through 12, and then once we're done we switch
Sounds
off?
good.
I have 2.
So we're doing 7. Are we doing the?
Hey, Caleb, can you pull your tray out a little bit towards you? so we can see it. Yeah.
Here, do you want to switch that? We're both doing the same.
The tray. Make sure you're doing the right column. Very important. And make sure your pipette does not touch the liquid in the well.
Say again?
10 would go in column 9.
Wait. I think I did this wrong. Okay.
Okay, so
Well, yeah, because column 12, column 12 doesn't have anything in it, so. Alright, okay. It's very intuitive. 12 goes in 11.
Wow.
10.
See what that's really
Wait.
concentrated. Let's see what the loot does.
Yeah, 10 goes in.
Okay.
Okay, alright.
Try to hold your pipetter as vertically as you can. Slight angle's okay, but if you're holding it horizontally, I'll mess it up.
Oh, okay.
What about it?
The plastic wrapper, the plastic cover.
Oh, thank you.
The plastic covering. Is there more of it so I can put this on top?
No, just leave it.
Okay.
They don't need to have the covers back on them.
Oh. Second brick. Okay, so you did 10, so I'll do 11 then.
And then I'll do 9.
Okay.
Row 8, AK.
David, we're going to have to pull the plug by a quarter to so that they can offboard. They've got quite a few steps to go through.
What if some of the wells on one of those trays doesn't match the wells on the other tray? What would you do?
Deal with it because something went wrong and
Take
Which
the
one?
average of the two colors.
Which one went wrong?
whichever one doesn't match the color key sheet that you have.
Oh, you're saying in comparing it to mine.
Well, because don't you have like a table thing that has all the colors in them?
Oh, I see. Yeah, in the classroom, we always assumed that mine was right. But sometimes a student would challenge me, and I encourage that. And so I do it again and find out, yeah, mine had been
Sorry, say
sitting
again?
for too long and it had changed color.
Yeah. So
That's my fault. That's my fault.
How do you spell that?
Yeah.
Okay. Just keep doing the pie. I'll be okay.
Yeah, no, yeah, I'll mess it up again. That's supposed to be.
Huh?
I messed it up.
Okay.
I put 4 in the actual number 4.
So what can you do if you messed up one well? Is that what you
It's
said?
5.
I had 3 before, right?
Yeah, you have 3. I have 4. You
Okay.
should have 5 and I have 6.
Wait, so why is 5 feels like 4? Wait, so why is 4 feel 10?
4 is still 3. I did 3. I did this one.
3?
No, no, I did 4 already.
Yeah, wait.
This is gonna be for 2, 3.
5 goes in 4, so did you do 5?
No, that's yours right now.
Yeah, I know, but the 5's supposed to be over here, and it's already filled.
2, 3, 4.
So one of the things you can see is that it's really easy to mess up,
Wait.
to get in the wrong place. Really easy to do that when you've got all of these 96 wells.
How did you mess up so
I don't.
Okay, this one's 6 right now. I'm doing 6 right here.
Okay,
Find
I'll
5
do
here.
5. I'll do another 5, which is supposed to be 6. Wait.
We're running out of time because we've got some things to do before you can leave. So we're going to have to stop this, but you get the idea of what it's about, okay? So what we need to do now is clean up. So for the 96 wells, you take it over to the sink, you turn it upside down, tap it a few times, run some water at the same time, and then run water into the plates. Now I have Q-tips there. If you make a mistake when you're filling it, you can use a Q-tip to clean out a well. But now, when you're emptying it, if some of them are stubborn, the color won't come out, you can use a Q-tip on it. That there's paraffin. Could you get that for me, please?
what?
The thing says paraffin. You see that? These, yeah. Bring me the box. Thank you.
Dump it out. Flip it. Yeah.
Hey David, does it matter if you use hot or cold water? Cold, okay.
Yeah, this will stain well. This is the one lab where I never tell my students that they don't want to put chemicals in their mouth. Because if somebody puts phenolphthalein in their mouth, it's an extremely powerful laxative. And I will know that they did it.
Yeah, the paraffin. That's what it's called.
I'm going to teach you. Take a tube, and you put this on it, and you stretch, and wrap around a little, and it's sealed. And then these that have the plastic parafilm on them, go ahead and replace those. 'Cause once they come off, they don't stick well.
Thank you. Oh.
Instead of messing with the Q-tips now, let's just, after you've emptied the tray, leave it filled with water and leave it in the sink. I'll take care of them later. Do the other tray also now. Please. Trash. And those two papers can be thrown away. We don't need those anymore.
Should we throw this away?
Yeah, if you got them all done.
I think we do.
Yep, okay.
Thank you.
And empty out the 2 beakers of distilled water. Yeah, and those can be set back into the shelf. Yeah, just empty them out right into the sink. And they either go on the top or the second shelf. So.
There you go. It's nice to see you tonight. Hello, Diego. Hello, Diego. Still don't have any audio. Hi, Trevor. How are you? Rishi, are you still with us?
Yeah, I can hear you, but nothing else.
Okay. We're starting to wrap it
And I
here,
can't
and-
hear you very clearly anymore. It's very quiet.
Okay. There's
I am here. Sorry, my microphone died again.
okay. Can you hear me now?
I can.
Yeah.
Okay. What we're going to do is go ahead and stop the recordings and so on. And I'm going to go ahead and let you guys go because the rest of it's just tear down and clean up. And I'm not going to ask you to stick around for that.
Thank you.
Have a good night.
There's a lot going
Bye.
on here. This was the first real effort trying to do work. Very, very
Bye.